So we've looked at differences of squares, we've looked at quadratic trinomials, we've looked at sums and differences of cubes, but what happens when we get into higher powers, fourths, fifths, sixths, and so on? Well, it turns out that we actually can factor these so long as we have a difference, subtraction sign between the two terms, and both terms have the same power. So if we look at example A, we have x to the fifth, so we need 32 to be something to the power of 5. Well, it works out that 2 to the fifth is 32. So the way we factor this, and I need a little bit of extra space because this is going to get long, we start off with the bases, x and 2. With higher powers, these always get a subtraction sign. Our big bracket, our large bracket, is going to follow a pattern. We always start with the first term, but we subtract 1 from the exponent. So instead of x to the fifth, we will have x to the fourth. This large bracket, every term will be separated by plus signs. Now we follow a pattern. We subtract 1 from the exponent on the first term, so x cubed, and we multiply that by the base of the second term, so 2. As we go through, we follow this pattern, subtracting 1 from the exponent on the first term. We're going to add 1 to the exponent on the second term until we get to 2 to the fourth. So we have x squared times 2 squared. Then we have x times 2 cubed. And we have 2 to the fourth. I would ask that you clean this up a little bit. X minus 2 is good the way it is. We have x to the fourth. We can clean this next term up into 2x cubed. We can have 4x squared. We can have 8x. And we can have 16. B, now our exponent is 7, so we need to look at 1 and say, well, what to the power of 7 is 1? Well, it's 1. So we will have x and 1 as our first bracket, and we follow the same pattern, except this time, instead of starting at x to the fourth, we're going to start at 1 less exponent than the original, so it'll be x to the sixth. Again, always separated by plus signs. We'll have x to the fifth times 1. Follow the pattern. X to the fourth. Let's make a good fool out of that. X to the fourth times 1 squared. Plus x cubed times 1 cubed. Plus x squared times 1 to the fourth. Plus x times 1 to the fifth. And lastly, plus 1 to the sixth. Clean it up a little bit. This one's going to look even nicer than A. X to the sixth. X to the fifth times 1, just x to the fifth. In fact, any of these terms that have 1 with an exponent, 1 with any exponent is 1. So we're just going to keep going. We'll have x to the fourth, x cubed, x squared, x, and 1.